Now come to the mechanism of strengthening. Means no, I mean you have already known that. I mean whenever you come to imperfection or defects, then you know what the kind of the defects are there, and that defects have the ability to slip. Okay, so now and one of the advantage that we have seen here in this picture, in this image, right? If you have the perfect alignment, or if you do some external effort, so you can take the advantage of that dislocation as well to make your crystal perfect. Okay, so that is known your, I mean how you, I mean what the kind of things, on the kind of your application that you can apply over your material, so that you can get your material structure perfect. That is known as your mechanism of strengthening. It means you can make a strength. I mean whatever the things that you have come to know, that I mean if there is a impurity, the imperfection, okay, in a solid, it means they are basically weaken your material. Okay, so strengthening means that how and what the kind of other your step that you are going to take, so that you can make your material or your crystal perfect. So that is on your mechanism of strengthening. Means to do something to either remove your dislocation or to manage your dislocation to make your crystal perfect. Okay, so this is the main thing. Yeah. Okay. So, so the strengthening mechanism is the relation between dislocation, motion, and mechanical behavior of a metal. Yeah. So, I mean, how you basically give a movement to your dislocations, so that you can have your mechanical property, desired mechanical property you can achieve. Okay, so this is simply, I mean, the relation between the dislocation, motion, and your mechanical properties. Okay, or you can say mechanical behavior. Behavior means the properties that you get, or do you that you received. The macroscopic plastic deformation corresponds to the motion of the large number of dislocation. Obviously, that I've already told you. I mean, the plastic deformation means your motion of dislocations. Okay. The ability of the metal to deform plastically depends on ability of a dislocation to movement. Whenever you see there is a plastic deformation, I've already make you know that, made you know that, I mean, what is the difference between the elastic deformation and plastic deformation. So elastic deformation means the deformation that can be recovered. Okay, when you remove the load, but in a plastic deformation you cannot regain your shape, you cannot regain your original position when you remove the load. So plastic deformation only occurs when there is a movement of dislocation. So dislocation movement is basically responsible for your plastic deformations. Okay, hardness and strength are related to ease with this plastic deformation. So they are the two processes which by which you can ease. I mean, which is for first one is the hardness and strength. Okay, are related to ease with which plastic deformation can be made to occur. By reducing the mobility of dislocations, the mechanical strength may be enhanced. Okay, so what kind of the things that you can do with your dislocation? You can reduce the mobility of dislocation. So if you somehow able to manage, or to control your movement of control the movement of your dislocations. Okay, so that will strengthen your mechanical properties. I mean, the strength of that particular material will get increased. What you need to do? You need to reduce your mobility of dislocations. So you have to control the dislocation so that they cannot move further. That is, it means you are able to increase the strength of your material. Okay. So greater mechanical forces are required to initiate the plastic formations. Obviously, in contrast, the more unconstrained dislocation motion, the greater is the facility to which the metal can deformed, and the softer and weaker it becomes. Obviously, if you are able to stop or somehow manage to reduce the movement of dislocation, it means you are increasing the strength of particular material. And just opposite to that, what happens if you are not able to reduce the movement of your dislocation? It means the material will have the ability to move their dislocation very fast, and movement of that dislocation will weaken your material. Okay. So virtually all strengthening techniques rely on this simple principle. Okay, so restricting or hindering the dislocation motion renders the material harder and stronger. So restricting your restricting your dislocations so that they cannot move further. That will increase your material strength and hardness. Okay, so basically it's all about, I mean, how that you play with your dislocation. If you are able to play that you can stop the dislocation for the movement, that is, I mean, by which you can get your material strength increased. And if you are not able to control the movement of dislocation, that will loosen your material strength and hardness. Okay,